Perfectly formatted JSON can still be completely wrong. The fields can all be present. The types can all be valid. The response can parse without an error. But the invoice total, as an instance, can still be wrong. Line item can still be missing, and the company name can still be invalid. Structure is not the same as truth. That is where Module 3 begins. In previous module, we focused on control flow. We learned how to read response state, wrote the loop, classify failure, and debug from evidence. Now we move from the loop architecture into extraction architecture. And the first move is not prompt polishing, a larger schema, or another retry. The first move is criteria. Before you ask Claude to extract anything, you need to define what a correct extraction must contain. You also need to define what an incorrect extraction looks like. The vague instruction such as extract this accurately sounds reasonable, but it gives your system no reliable way to score the result. Accurate compared to what? Which fields are required? Which values may be missing? What happens when the source is unclear? What counts as a false positive? What should continue downstream after validation passes? Without these answers, you do not have an extraction contract. You have only a request. A useful extraction decision defines required fields, allowed missing values, source ground rules, semantic checks, retry feedback, and the final saved artifact. Those decisions come before prompt refinement, because if you cannot score the output, the prompt is still underspecified. Use for pass or failure questions. First, what facts must appear? Which values are required for the downstream workflow to function properly? Second, what may be null, missing, or unclear without failing the whole extraction? Not every absent field should be treated as a failure. Third, what counts as wrong? A fabricated value, a missing row, incorrect arithmetic, a value copied into the wrong field. Fourth, what artifacts should continue downstream after validation passes? These questions turn extraction from a writing task into a measurable system. If you cannot score the answer, you are not ready to optimize the prompt. Better wording may make the response sound cleaner. It may make the output more consistent. It may reduce obvious mistakes. But better wording alone doesn't create a measurable success conditions. That distinction matters in production. And it matters in certification questions. Now let us use the invoice example. The source contains an invoice identifier, a company name, a currency, a tax amount, a total, and 2 line items. This source facts becomes the extraction criteria. Notice the direction. The source creates the contract. Then the schema and validator enforce that contract. Do not start by investigating a large output object because it looks comprehensive. Start with the facts and source can actually support. If the source contains an invoice identifier, define the invoice identifier field. If the source contains 2 line items, define how these line items must be represented. If the source doesn't contain a per-cached order, do not create one. The correct output may be null. It may be unclear. It may require review, but it should not be fabricated. Now consider the total. The total is especially useful because it gives us a semantic check. Suppose the output is valid JSON. The total field exists. The total is a number. The schema accepts it. But the source says the total is 1,620. And the output says it's only 1,500. The shape is valid. The meaning is wrong. That is why schema enforcement and semantic validation are different layers. Schema enforcement asks, does the output have the required structure? Semantic validation asks, do the values agree with the source and with each other? A schema can require a subtotal field, a tax field, a total field, but your validator still needs to check whether subtotal plus tax equals total. The number of extracted lines items matches the source. The currency matches the document. And each value comes from supported evidence. A valid container can still contain bad facts. That is why the rubric must come first. Once the criteria are clear, prompt improvement becomes bounded. You are no longer asking how I can make this prompt sound better. You are asking how can I make the system pass defined checks. Now let us talk about the false positive. A false positive is not just awkward wording. It is not a cosmetic mistake. In an extraction workflow, a false positive can be an architectural failure. If the model invents a per cache order, a downstream system may search for an order that doesn't exist. If it places the subtotal into the total field, an accounting workflow may act on the wrong account. And if it misses a line item, the invoice may be approved with incorrect data. An automated workflow may send private information to the wrong recipient. That is why vague instructions such as be consistent or only include information you are confident about are weaker than explicit evidence criteria. A stronger rules sounds like this. Return a per cache order only when the source contains an explicit labeled per cached order values. Otherwise, return null. High false positive rates also damage truth. When the users see fabricated values in one category, they begin to suspect that the other categories are fabricated too. Reliability is not only average accuracy. Reliability is knowing which output are safe to trust. Now use the criteria ladder. The first level is source presence. Does the source actually contains or support the value? The second level is schema shape. Does the output have the required fields, type, and structure? The third level is semantic validation. Do the extracted values match the source and satisfy the business rules? The fourth level is retry feedback. The validation fails. Can the system explain exactly what needs to change? The fifth level is the saved final artifact. What validated result is safe to pass into the next workflow? That is a complete pass: source, shape, meaning, feedback, and trusted artifact. Do not use prompt wording as the only enforcement layer. Prompting is useful. Prompting explains the task. Prompting communicates the criteria. Prompting can improve extraction behavior. But prompting should not be the only thing standing between a bad extraction and downstream automation. You cannot enforce or validate a contract that nobody defined. Now let us open the course download pack. Open the structured output pack, then open the extraction criteria worksheet. The point of this worksheet is not to list every field that could possibly exist on an invoice. The point is to make the pass or fail contract explicit before you change prompt or build a retry loop. Start with the source example. The worksheet identifies the invoice identifier, a company, a currency, subtotal, tax, and total, and the two line items. These are source-supported facts. Now look at how the worksheet converts those facts into the required output fields. This is the work you should complete before writing a more elaborative extraction prompt. Source first, contract second, prompt third. Now separate required fields from optional or nullable fields. The invoice identifier may be required. The company may be required. The currency may be required. The line items may be required. But suppose the source doesn't contain a per cache order, or a due date, or a contract person. The correct behavior is not fabrication. Depending on the downstream needs, the correct result may be null, unclear, not present, or a structured review node. The rubric must define which one is allowed. Now look at the semantic checks. Required field checks prove that the extraction is complete enough. Arithmetic checks prove that the amount agree. Line item checks prove that no source rows disappear. Source grounding checks reduce fabricated values. Field placement checks confirm that subtotal, tags, and total are not confused. Now look at the false positive risk. Fabricated values, missing line items, incorrect arithmetics, values placed in the wrong fields, unsupported assumptions. These are not random examples. They are the values that would make the downstream artifact unsafe. Now open the output rubric. This is a fast review version. Required fields are present, total matches the sources, line items are complete. Currency is captured correctly. Unsupported fields are null or flagged. And the validation result is saved for downstream use. Now connect this to the exam lens. The exam will give you a symptoms and several plausible levels. Your job is to identify the owning layer. If the team never defined what correct means, the owning layer is criteria. The first level is a measurable rubric. If the output structure changes between calls, the owning layer is schema enforcement. The level is structured output or another explicit structural boundary. If the output shape is valid, but the values are wrong, the owning layer is validation. The level is source-grounded or semantic checks. If validation identifies a specific, repeatable problem, but only when the feedback changes the next attempt. If the source doesn't contain a required fact, the level may be clarification, retrieval, null value, null handling, or human review, not fabrication, not repeated prompting. So reject answers that polish wording when the values belongs to criteria, enforcement, validation, or review. But only after the architecture knows what it is trying to enforce. Use this ranking semantics. The system has not defined what correct means. The owning layer is criteria. The best level is an explicit pass or fail rubric. I rejected prompt polishing because better wording doesn't create a measurable contract. That is the module 3.1 mindset. Your next action is simple. Open the structured output pack, complete the extraction criteria worksheet. Then read the output rubric. Keep both besides you while practicing the exam questions. Before moving on, make sure you can answer 4 questions. What facts are required? What may be null? What counts are wrong? What validated artifacts continuous downstream? In the next lesson, we will ask where structure should be enforced. Plain JSON instructions, unstructured outputs, strict tool inputs, or application validation. That comparison will make sense because we now have the criteria first baseline. Define the contract first, then choose the enforcement point.